Hi folks, welcome back to Physics with Captain Rod. I'm making these videos to help you out with 11, 12, and 13 here in your Unit 1 homework. So these are all vector addition problems. So basically the same as the previous ones you worked on, other than they're about compasses basically and bearing types of problems. So just really the trick is getting the pictures right. Let's talk about this first one here. Number 11, a person gets into a car and drives 20 miles north and then 15 miles 20 degrees south of west. So I'll go ahead and give you an idea what that picture would look like. All right. So pretty much the same as any vector addition problem. Start by putting in a coordinate system here. So x, y. And this one is about displacements like on a map, north, south, east, west. So I think it makes probably pretty good sense to say, all right, let's call this east and this north. And then south would be this way and west this way in our picture. Now we're not going to probably need those arrows. Let me get rid of them. So that very first one, let's see, a car drives 20 miles due north. So we're going to draw a displacement vector. I'll go ahead and draw that for you. That might look something like this, 20 miles. Now, how long you draw that vector really isn't important, but at this point we have drawn or set a scale. So 10 would be, roughly half of that, 40 would be roughly double that, and so forth. All right, next, 15 miles, 20 degrees south of west. Now, the important thing to realize is you want to draw that from here, from this point. So if you have to, imagine another little coordinate system here, like x, y. And 20 degrees south of west. Now, this direction is west. 20 degrees south would look something like this, where that's a 20-degree angle. And that vector is 15 miles long, so it's going to be, somewhat shorter than the other ones, so maybe something like this, probably good enough. Then you draw your resultant vector. I've done enough on this problem, it's virtually done. And then just like all the previous problems, write those vectors in unit vector form, and let's talk about the first one here. That first one does not have an x component, so 0i, right? And then the 20 miles is the j component. So that first one is 0i plus 20j. Do the same thing with this vector and then add the components. All right, number 12. Let's see, a person gets on a boat, travels 10 miles west. So similar to number 11, start with a coordinate system. Then draw this first vector, 10 miles west. All right, next. After that, you draw a 15-mile vector at a compass bearing of 300 degrees. All right, so compass bearing, that's probably the first homework problem that showed up. A compass, here's how this works. If I call this east and this north, a compass reads with respect to north. 0 degrees on a compass is north. East is 90 degrees on a compass. South is 180, west is 270, and so forth. So when you draw this vector, draw it at the appropriate angle. Draw a little coordinate system, then it's 300 degrees clockwise from the direction north, and then draw that. Next, draw a 5-mile vector at a compass bearing of 40 degrees. Then draw your resultant vector. Write each of these vectors here, here, and here in unit vector form, and then add up the components as usual. That should get you through most of that problem. Okay, number 13, two vectors are added together. A is 20 units long, makes an angle 35 degrees clockwise from the negative x-axis, right? So draw on a coordinate system, x, y. Now the negative x-axis is referring to this. So you're going to draw a vector 35 degrees clockwise from this. And that vector is 20 units long. Now the second vector that's being added, we'll call that vector b, is unknown. So we can't really draw it yet. But what you can draw is the resultant. The resultant is 40 units long at 200 degrees. So the resultant, you're going to start here, and 200 degrees is down into quadrant 3. Once you get that done, you can draw a picture of the resultant, and that should get you probably going on 13. And I think what I'll do here, I'm not going to do it in this video, but I'll make up an example video fairly similar to this with completely different vectors, so that should help you out. So I'm hoping that'll get you rolling on those 3 problems. Have a great day.